Well, hi, good morning. Thanks so much for joining me in my shop. Pretty excited actually to go to the next step here with this amplifier. I'm excited because at the end of the last video, we heard one channel work. It seemed to work really well, in fact. And then I swapped out moved all the tubes over to the other channel. And we got a big fat 0 on that. So that sounds like fun. That sounds like surely to goodness there's some way to get this side working too. One side works, the other one should too. That's what I want to really say. So now, is it possible there's some kind of setting thing here that I didn't get right? I don't think there is. Or is there something dumb I did? For instance, yeah, these tubes are right. Yeah, let's check the dumb things first. Speaker plug is in. Maybe this isn't, maybe the volume control I did, I've got a mistake in the wiring. It's possible. I've got the input signal. I moved it from one side to the other. You know what, I may not have done this right. I'm trying to remember now. Good. Excuse me. Trying to remember which of the 3 input prongs was the ground. You know what, I had the ground right. I never moved it, so it's still right. So this has to be correct. So I should really double check this volume control, and it's pretty easy to do, really. Hey, one of these is, hey, look at that. Huh. One of them's not in. There we go. That's probably the problem. That's probably it. That's probably it already. Probably from moving the volume control around, it's probably the one short wire, you know, the shortest wire. Here, I'll bet you that was it. Okay, now don't make the mistake of thinking, find one mistake, that's probably it. Maybe there's more. What else could there be? The only other thing on top here is that, and that sounds good. Okay, let's try it again. Plugged in. Okay. Volume control down a bit. Audio signal. Bring in the audio signal here. Excuse me. The output of this signal generator is generally fairly low. There we are. So I tend to have this up pretty high. But to start, let's put it down. Let's not make it. Once again, I do not want this thing screaming as soon as it comes on. There we go. First, dim bulbs. Perfect. Operation there. 6.3. Okay. So 6.3 next. Here we go. 6.3 volt heaters on these tubes. Got some vibrations coming out of the tubes. So the actual supply voltage is just under 100 volts. That's actually dropping. It's closer to 90 now. It's still dropping. So at 90 volts, maybe this can't work. I don't hear anything. Let's try the volume. Okay, so I can hear a hum and I can hear a buzz. Careful now, I got the volume up full. Let's turn it back. The volume full, at any moment this thing could come on. And I don't know how loud it would be. My guess is really loud. I just want to know which speaker it was that was making that noise. Good show. Okay, so it's the speaker that attaches to this. The other speaker is silent, of course. It's got no tubes to drive it whatsoever. Okay, so we're hearing something coming from the output. Nothing getting through from the input. So our problem lies somewhere between here and here. Good. Let's turn this up a little bit and jack up the input. So the input's at about 2000 hertz, and Let me really jack it up here. We're going to give it the boots. Something is making sound. Don't know what. Next possibility, easy possibility here. Gain volume. Oh, I had that up way high. Okay, that's good though. Just turn it up a little bit. Could be just bad tube contact. Not very likely. I don't hear a thing from any of that. That's a pretty poor test. Could be we're running on 85 volts. Could be it's just not enough voltage here. Some tube is in cutoff. So we're going to give it full voltage, volume down, input down, full voltage. Okay, volume up. Input signal up. So something is making that sound. It's coming right out of here. Okay, so I think we'd be pretty sure it's not working. Now, I got to get at this channel. You know, if I flip it around, put it on its side, this part up, I think something's getting hot. Something getting hot here. Oh, it's this tube. It's just the tube. No heat. No heat anywhere else. Okay. Right. Power off. Flip it around for troubleshooting. Just getting in a moment. That's I gotta remember two power switches. I gotta remember. Okay, all power off. We'll flip this thing up and over like this. Stabilize it with a block. It's pretty good. Swing around. Okay, we made it. It's all the stuff down here. All the stuff down there. Oh boy. So now the input is over here. There are two little transistors right at the very start. They are look at all those parts in there. That's one of this type of capacitor back dug way in there. You can see the capacitor lead comes around the outside of this terminal. There's another one right here. There are more of those? Are those replacements in there? Let me look way up. You know what? If I look. I can't quite see what's up here. I'm looking for the matching one. It looks like the same kind of thing. Okay, so what are we going to do? We're going to start by tracing back the signal right from here. You know what? I'm not going to be able to do this way. I'm just not going to be able to work on it. I'm going to have this thing right upside down. Right, flipped right over. Okay, let me work on setting this up so it's convenient to work on. I think a lot of work is coming. So I decided to put the camera on because it'll be more fun for you to watch me drop this than to hear me describe how it fell off camera. So I'm going to flip it up and use this. You know, this is the kind of thing you buy for your shelves. Put your cans of soup on. Very handy, guys. Here, let's move this back. Put this here. Think about the cords. Any cords? Cords should be okay. Way up. Way up and then down. Okay. What are we on? Good. That's actually really good. Excellent. Excellent. Let's say that one more time. Excellent. That's a 3 times excellent thing. Fantastic. Input in down here now. And look, there's no story to tell about how I ruined this whole thing. Dropped it or something like that. Great. Okay. Input end. Lots of parts changed. This is the output end. Output end. Lots of parts changed. Lots of parts look like they should be changed. But it's the input end where we want to start. We're going to try to trace the signal coming through here. Yeah. I gotta do something a little different with the camera too. Let me get this stuff. I gotta get this set up right. Okay, I think I got a little bit of a better range. I got my Sky camera right there. We're going to switch to that camera. That should give us lots of close-up views. Let me put on my own big screen TV here. And we're going to try to zoom right into the area. Well, we can see all 4 of them there, where the transistors are. The transistors are plugged in. That's another thing. They aren't soldered in, they're plugged into sockets. I guess that's the echo of tubes or something like that. First, or maybe there was a big expectation they were going to change these out a lot. That's probably really what it was, and they wanted to make it so the repair guys didn't have to whip out a soldering iron in somebody's restaurant. So there's the transistor guys there. And which side am I? So we're working on this side here. So I'm just gonna get the signal tracer out. I just realized my signal tracer has a limited cord on it, so we're gonna have to rearrange again just a little bit here. This guy way over here, way over there near my signal tracer. Switch on. So I don't even have to have the unit on to really start the very first step. I think, is the signal making it to the first transistor? That would be a good question. Let's bring over the Skycam. Out light interference, everybody. Okay. Actually, it's not a Skycam, it's a crane camera. Okay, I'm gonna... Here. Signal tracer getting set up here. It's on RF. We want it only on audio the whole time here. Okay, just checking my attenuator and all. Everything's ready to go. Can I reach it? Yeah, I can reach it. Okay. Signal's being fed in right now. The level is high. Should be easy to find it. The actual input is right in here through these capacitors. So let's start right with the let's start with the start. Here we go. Should be here. It's there. It's a pretty high tone, isn't it? Something funny there. What's going on? There's so much dirt on these connections that touching them doesn't do anything. You have to break through the dirt. There we are. That's just too high a tone for me. Now it's not going through the transistor or anything. Nothing's on here. I don't have the power on. But it's making it to the bottom of the plug. Let's go to the other side of this transistor, or capacitor rather. And then from there, it looks like it's on the green wire down to here. So it's making it to the transistor. Okay, from here we have to have things operating. Okay, so safety check here because I moved everything around. Let's look at the cords. Everything looks perfectly fine. I was pretty careful when I moved it, so I don't think there's a problem there. I think we're ready here. Hey, what's with the focus on this camera? There we go. Okay, I gotta get my hand on the volume control and make sure I know which way is which. Okay, so that's the volume down. I'll turn it up a wee bit. And the speaker plug stayed in. Yep. And the high voltage connection still good. Okay, everything's good. Power going on. We'll just use the restricted power. Swallow deep and hit the switch. Dim lights are doing their thing. So what I'm going to try now is see if the signal gets through those two transistors. Easiest way would just be to go to the second transistor and try to pick off the output. It's either the yellow or the black wire down there. Okay, my hand on the tracer volume control. Let's just double check, make sure it's reaching the first. There it is. Reaching the second. Sounds a lot different. Coming out. Coming out on here. Okay, I think we found something here. So here it is. Pretty sure that's going to be the bass. That doesn't sound right. Hear that? Hear that? Doesn't sound right, does it? Then over here on the base of this one, and then on the output side of this, nothing. Ooh. Okay. So from that we can quickly conclude, but maybe not conclude correctly, the transistors are mucked up. Not necessarily. It could be bias problems on them. They could be just fine. And one possibility is they're just not making a connection in the connectors. Now these situations where you have, like a 2-pin plugged into a socket, all those kinds of pin and socket situations, in my imagination, I think when they have not been, if they're working and they have not been disturbed over a long period of time, then probably it's best to leave them totally alone, because the slightest disturbance will only worsen or make the situation bad. So yanking them out, putting them in, could just introduce problems where there wasn't any. We could do a little DC study on these guys. Don't forget this amp is on. So why don't we can do the comparative. Can we do the comparative thing, left or right? I think we probably can. These are probably still, the other ones in the other channel are probably operating completely right now. Probably. It's the tube parts that are not operating. So to get that together, I got to fiddle around here a little bit on my camera. So hang on a sec. Okay, so we're going to read these voltages to the chassis. Now obviously they're going to be on this meter, which is set to 20 volts DC. That should be okay. It's more than 20, that's no problem. Just untangle my lead here. Okay. Units on with reduced voltage. The voltage has been reduced to, it's 100 volts now, exactly. 100 volts coming into it, AC. That should give us pretty good voltages. Now we'll start on the side that was working. And we'll go right after this green wire here, and we'll see what we get. some trouble getting accurate readings here because of the contact issues with the stuff in this player. -2. Okay, so we'll try the other one now. This is the other. I think these things should all be biased the same way. -0.6. I need a needle on the end of my. Careful, Jim. I just realized I've got the palm of my hand right on the chassis here while I'm doing this. What that means is I'm grounding myself right to the chassis, and that's just. It's not the best, but I got to do it. So we're getting a little bit of a different reading here. About half. -1 on one of them, and on the other one. Oh, how'd that get up to -3? Why is it drifting up and down? Back to here. So we get -3 and -1. That's kind of weird. Now we'll do the questionable side. The side we're working on. We'll get something totally different. First one. Oh, wait a minute. I'm getting the -1 here. Is that really true? -1, and then if I go to this other guy, oh, isn't that weird? They're all over the map. So that's the bias side of things. Okay, well, we'll try the, we'll do the black wire in every case. Okay, black wire, -7, okay. Black wire, -11, that's a little more like it. Different, eh? Black wire down here. Okay, about the same as the first. Black wire over here. Ooh. Wait a minute here. That's quite different. That just doesn't seem right. Pick up the black wire. Watch your fingers, man. Watch your fingers. Jesus. Excuse me for that. Pretty close to sticking my fingers right in here while I'm working. Get a lovely close-up of me shocking myself there. Okay, not that there should be real high voltages right in this area, but I don't know. So we have -2. Wow, this just does not sound healthy at all. Okay, around on the yellow now. It'd be useful if I wrote all this down. -3, isn't that what we saw over here? No, we saw -7 here. -3 over here on the yellow. And -11 up here. 7, 11. And on the yellow again. Okay, over here on the yellow. And the thing that would really jump out is a 0. That's pretty high. -2 point something, 2.5, and on the black wire in the same one, it's the same voltage. Ooh, isn't that bad? So on one side of the, it's either the base or collector. I'm sorry, it's either the emitter or collector. On one side we get that. On the other side we get basically the same thing. Ooh, how do you spell short? Okay, power off. How do you spell short? So my options at this point, I can pull these transistors out of their holders, and I can do a transistor test on them. I have a fairly reliable modern transistor tester. I think we'll probably, and it gives parameters, so we could do that. But thinking about that thing I said about, breaking the ancient contact, so I don't want to be quick and pull these out. Not at all. So this could be representative of transistor trouble. But the fact is, this side seemed to work okay, even with the voltages on it. Now I never saw what might be a short. Let's try this now. This will be interesting. We'll just flip my ohmmeter to ohms, my multimeter to ohms. Let's go down like that. And I'm just going to test all those contacts again. What happened here? Wow, it's not easy to make contact to this dirty chassis. I got to find a better spot. I got to find a more legitimate connection point. I think there's one in here. I think this one would be better. There we go. Okay, so we're just going to read the resistance of each of those 12 contacts to ground again. A comparative test. It doesn't really mean anything in itself unless we find something wild like a totally open. Yeah, let's do it in order. We'll do grids first. All grids. Grid. Nothing. That's okay. Let's just keep going. Fool with the meter in a minute. Nothing on that grid. Nothing on that one. I'm not getting anything. Is this thing working? Other side. I did them all, didn't I? Grid, yeah. Okay, now black wire all the way around. Black wire. So if this looks like a fishing expedition, that's what it is. Black and black. Now we'll go yellow. I think I just have my voltmeter set so low, but I am looking for shorts. What did I hit there? And I got something out of that. This one's looks like it's charging up a capacitor that's just charging fairly rapidly after I let go. That's the working side though. Okay. Yellow. Hey, what happened there? That's the yellow wire. Did I see a negative on there for a moment? $200K. How about this one? So that did the same as its brother across the way. This 200K thing. Let's go check his brother. No 200K. I just have it set too low. Let's put it up. 2000K. I had it at 2000. Just ignore what I'm saying. Okay, so let's get some readings here. Okay, so on this pin, oh. This pin. I would take 12. I would take 12. Over here. So there's a voltage setting there. That's why I'm getting a negative reading. Some kind of voltage charge sitting on it. Why is it sitting on there? But not sitting anywhere else. This really calls into question all these own meter readings if there's voltages on. What voltage? What voltage is sitting on there? Minus 1 volt. Where are you coming from, Mr. Minus 1 volt? It's coming from somewhere that's got a bit of reserve. But the other doesn't show that behavior at all. So in my travels here, I've encountered lots of bad capacitors that have moisture in them and develop a galvanic charge. That's my opinion on them. And you can pull these capacitors out and test them like they're a battery and see a voltage on your meter. The batteries are so weak they can hardly drive even a 10 megohm meter. So when you hook them up, you'll see it bleed the charge away pretty quick, but not entirely, because there is a little bit of EMF inside these capacitors. So is that what I'm reading? That's a very low voltage there, and it's extremely low. Where else could it be coming from? Storage capacitors leaking all the way through the circuitry all the way to here. So, you know, what's rolling around in my head is how many of these parts are bad? How much of this stuff is out of sorts? I think the short answer is a lot of it. So I couldn't figure out anything too conclusive here in what I just did. With it operating, I found a signal appearing here on the grid, but by the time it appears here, it's already distorted. Where? Here. It's already distorted on the first transistor. The voltages and resistances are just varying all the way through here. Nothing so dramatic as to make me jump up and down and go, haha. You do have the possibility of swapping the transistors over, moving from here to here. Again, everything I do to these transistors, are they mechanically tolerant? They probably are. You probably can pull them out, put them in, and not, you know, you're flexing the leads a bit on an old precarious thing. But the fact is, if I swap these around or fool with them and thereby introduce a new problem in them, then I will become even more confused and lost on this whole thing. If I were to take them out, the only purpose is to test them. And you know what? I really need replacements standing by. Wow, we didn't make it even through here. So I'm gonna do off camera today, during my day. I'm gonna study up on this whole area of circuitry in here and get a good understanding how this works. I think it's pretty straightforward. Probably just two series amplifiers here, and you know, here's a fairly high wattage resistor here. What's happening in here? There's these capacitors that I was questioning, which I can see more clearly now. Look over here. Look over here. Look over here. Hard to see in the camera there, but there's a teardrop there and another one here. There's a little tiny guy right there. What is he doing? It's just this little tiny thing. No, a little tiny capacitor, like a tantalum. I think those are tantalum capacitors. A little tiny guy there. Looks like he's right across the bigger one. Okay, so I can't sort out if somebody's really worked in here or not. Again, the lead from this capacitor is brought up around the outside of the terminal and just ends in the air here. This does not look like factory work. I wonder if from time to time the jukebox manufacturer would put out a bulletin to the repair guys saying, okay, just next time you're on this guy, go in and change these two capacitors. And so here's a kit. Maybe they mail the parts out to them. Or, you know what they could have been doing is they're constantly swapping these machines. The field guys working the jukeboxes, the field technicians, they come in, they got trouble on the jukebox, one channel not working. Out comes this amplifier, in goes one that he just got back from the repair service guys. In it goes, checks it out, working good. This one goes to the shop. In the shop, they do troubleshooting like I'm doing, and then they also do standard changes that they've come to know. When any of these units come in, change those capacitors, because they're going to be trouble. That's a pretty good story. Once again, I don't know if any of it is true or not. It's not helping me make decisions here, though. or is it? So let's just go over the options so they're clear in my head today. First option is understand this better. Oh, for sure, that's got to be done. Second option is pull out these transistors and test them, or test them somehow. Maybe I can even test them in here. No, I'd have to pull them right out. I have a good tester. I can certainly do a comparative test. These are no mystery, these transistors are well-known transistors, 2N109s. So their parameters are well-known. So testing them out is definitely a valid approach. It just comes with that risk I was talking about. Checking all these components in here, pretty difficult, but maybe there's a shorted capacitor or something I can find. So the other thing to do, check all the components. Maybe there's a table of voltages in the manual somewhere. The manual I've got at this point I think is a simple manual, but sometimes voltages are listed all over the place. You just go in and measure them up and find something out of sorts. What are the chances that now I have the voltage, the volume regulator tube in here. I had it in over here. Maybe this guy's? No, I don't think so. No, he's after the transistors. We didn't even get through the transistors. Really. That's what this is showing. Okay, just because this side's working, it doesn't mean it's working properly, the voltages are correct, or anything like that. Sometimes when you have problems in devices, upping the volume compensates for those problems perfectly. So whenever you have a loss of volume because of a problem, but you can't really know that when you're just running your machine. So you just turn the volume a little bit higher. Is that higher than it should be? How do you know? So I think you can have a lot of problems building up in something like this, draining out the power left and right, and in the center too. And the result is you just keep turning up the volume a little higher, a little higher, a little higher. And you're going to get along with that some noise and stuff, but how many people even care about that? Hey, you're in a restaurant. Oh my gosh. You want to go to a noisy environment, go to a restaurant. Man, these jukeboxes had to beat back the restaurant sound. Frank doing the dishes in the back. Oh my gosh. Tough job. Okay, that's enough yapping. I'm going to go away and do what I said. We'll see what happens tomorrow on this. Thanks for watching again.